In a previous video, I introduced you to the derivatives of the 3 primary and 3 secondary trig functions, but I just gave them to you. I didn't really give you any explanation. In this video, I'm going to use the definition of a derivative, sometimes called the delta process, although I replaced what's often delta x with h just to simplify it. And we're going to use that to find the derivative of the sine function. We're going to show that it's the cosine function. And that'll just prove one of the formulas that I gave you before. And we're going to use that then to show where the other derivatives come from. So for this example, we're going to say f of x is equal to sine x, and we're going to show that the derivative has to be cosine x. So what we want at the end is f prime of x equal to cosine x. Hopefully now we know that that is true, so we want to show that that's true. The derivative of sine is cosine. Here's the definition, or the delta process, that we use to find the derivative. Really, this should be f prime of x equals this. Since f of x is sine x, we're going to replace x with x plus h. So to find the derivative then, f prime of x is going to be the limit as h approaches 0 of sine of x plus h minus sine x all over h. Let's just separate that there a little so we can see what we're dealing with. So this is what we want to show. This is the first step here. So we've replaced x in our function with x plus h, and here we just left sine x. Now, on the right here we see we have a trig identity for the subtraction of two sine values. So the sine of a minus the sine of b gives us this expression over here. And in our example we have x plus h for a, so we're going to say a is x plus h. And everywhere we see a, we're going to write that in. And b, pick a different color here, b is going to be x. So b is just going to be x. So everywhere we see b, we're going to write x. And that's how we'll simplify the numerator, and we'll just leave h in the denominator. So we'll go ahead and do that. The limit as h approaches 0 of, well, we're going to get 2 sine of a half a minus b, so a is x plus h, and minus b, which is x. So that's this first part here. So then that's times the cosine, so now we're doing this, of a half a again, which is x plus h, plus b, which is x. I need that extra bracket there. And that's all divided by h. So there's our numerator simplified. Now we'll take it one step further. We're going to do a couple of things here at once. First of all, we're going to take this 2 and we're actually going to bring it down bottom, which is kind of counterintuitive. We don't usually want to put an extra fraction in the denominator, but hopefully you'll see why we do that now towards the end. So we're going to get rid of that 2 by bringing it down here and dividing the bottom by 2. And we're going to simplify in these brackets here. So what we end up with is the sine of 1/2 h. X minus x is gone, so those kind of cancel. Those are gone. We're left with just h, so this is a half h, or h over 2. Then we get cosine. We get x plus x is 2x. 2x times a half is just x plus h over 2. And that's all over h over 2, because don't forget this 2 we took down here. So this is what it simplifies to. We can write that in 2 parts. So the limit is sine of h over 2 over h over 2 times the cosine of x plus h over 2. And the reason we're doing that is because now we can use this property here, and it's possible to prove this, but for the depth that we're looking for here, we're just going to accept that this is true. When you learned about limits, you may have looked at this special limit, but if not, that's okay. Right now, you can just take it at face value. If you want to see a proof, it could be done, but we're not going to worry about it right now, maybe in a later video. So this says that if we have the limit as x approaches 0 of sine x over x, the answer is 1. Well, that's not exactly what we have. We have the same situation. Here, if you put in 0, you get sine of 0 over 0. Here, if we put in 0, we'd end up with sine of 0 over 0. So this formula applies to this situation. What that tells us is that this part of the limit goes to 1, which is what this says here. If we replace h with 0 here now, we're going to get the cosine of x plus 0, and that tells us then the solution to the limit, and let's try one more color here, is simply the cosine of x. And that is our derivative. So we've now proven that given a function f of x equals sine x, the derivative is the cosine of x.